Okay, so we are in lesson 3, operations with functions, and we started this yesterday when we were talking about the two functions and we were talking about them being added and subtracted. So today we're going to do lessons 3 and 4 and we're going to talk about them being multiplied and divided. So as per yesterday, when you have the two functions, you have a value for x, and when x is -4, then we have two different y values, two different outputs, one for f of x and one for g of x. And when we multiply those together, we can literally just take the points, the values of f of x and g of x when x is -4, for example, and multiply them together. So to fill out this chart, that happens really quick. We just take these numbers, we multiply them together. So take -7 times -7, and we get 49. And you can fill out this chart by simply multiplying those two values of f of x and g of x together. So they are the outputs of the two functions, and we can just times them together. Oh. So what happens is that when you have f of x and g of x and you multiply them together, you actually get a new function. So we've done part A here. We've completed the table. We've multiplied the two values together. And now we can actually plot them onto the grid and see what we get for a new picture. So when x is -4, we have 49, which is way off the charts. So we'll skip a couple of those values. Let's go to when x is -2. Let's do this one right here. So when x is -2, we've got 15. So -2 and 15. We're going to plot that point up there, and then we'll go ahead and do the other one. So when x is -1, we have +4. When x is 0, we have -3. When x is 1, we have -6. When x is 2, we have -5. And so on. We can keep plotting those points. When x is 3, we have 0. And when x is 4, we have 9. So you'll notice that's looking a little bit like a parabola, and that's what it is. So if we want to draw those together, you have this picture looking like that. So it's a parabola. And the next part, part B, says the functions, they actually give us what the two original functions are. They say the functions f and g are above, or f of x is equal to 2x plus 1 and g of x is equal to x minus 3, right? A simplified expression for the function. So we don't just have to do the table, we actually have to do the multiplication of the function. So we're going to do this. F g of x is going to be equal to 2x plus 1 times x minus 3. And you're really good at multiplying that out. When you're done, you'll get 2x squared minus 5x minus 3, which is what we expected because our picture was a parabola, and so we expected to have a quadratic function for it as well. So we could compare, we could plot that in and see if it looks like ours. It will, so that's great. Let's talk about the domain and range of the function. So you're all good at this now, you remember. So for domain, we have x as an element of real numbers because it's going both ways as you go left and right. And for range, we're talking about the y values, we're talking about going up and down, and there is a minimum value. Now, here's the problem. My minimum kind of looks like it's at -6, but it probably actually isn't because I haven't plotted. I mean, I don't know for sure if that's exactly symmetrical, and it's not. So you need to plot this in your graphing calculator. Plot this function here in your graphing calculator and find the minimum value. When you find the minimum value, you will discover that that little point right here, this -6, is not the actual minimum. It is slightly to the right. So actually, the minimum value is going to change my range. So my range is going to be y such that y is actually greater than -49/8. Pretty close to -6, but it isn't exactly. So you'll need to graph that function in your calculator and come up with that minimum. The other option would be to complete the square, but that's kind of tedious. So now it says calculate the value of f of g of 8 in two different ways. So you can do this two different ways. You can plug 8, this number 8, directly into the function 2x squared minus 5x minus 3, the quadratic, or you could do them individually. So those are our two options. So if we could do f of 8 and multiply it by g of 8. So I would just take 8 and plug it into 2x plus 1. This 2x plus 1, just put 8 in there, so 16 and 1 is 17. And we're going to put this 8 into g of x, which is x minus 3. So that's 5, because 8 minus 3 is 5. And when I times those together, I get 85. That's one way. Or we could take the composite function right here, f of g of x, which we found out to be 2x squared minus 5x minus 3. So let's do this one. And we can just plug in 8 there. So we're going to go 2 times 8 squared minus 5 times 8 minus 3. And when you do that, type it all up, get it all, you'll get 85 as well. So either way works. You can go into the individual functions and plug in 8 and find the value, or you can times them together first and then plug in the 8 to the quadratic that we did there. So letter G here, it says complete the statement. In this investigation, the product of two functions whose graphs are straight lines, if you have two linear functions and we times them together, we get a quadratic. Now, can you find two functions whose graphs are straight lines when this is not the case? Any two straight line functions where it's not the case? Yes, there is one. How about if we chose f of x just to be x, and how about g of x to be just a constant like 5? Now when you times them together, you just get 5x, which is just linear. So we found something about true in this investigation, but there is a case whenever you have a constant function like that, it won't be linear. Or I mean, sorry, the multiplication of the two functions will not be quadratic. All right, let's go on. Okay, so on this next page, it says consider the functions f of x equals 3 root x minus 2 and g of x root x minus 5. We did this yesterday. It's pretty straightforward. You simply take the two functions and you subtract them together. So we're going to go 3 root x minus 2, but watch carefully with your brackets, because right here, it's where kids make a lot of mistakes. They forget to put this bracket in, so then they don't get the signs right. So we get 3 root x minus 2 minus root x plus 5. So put brackets around it so that you don't miss that. So 3 root x is take a root away of root x is 2 root x, and a negative 2 and a positive 5 is a plus 3. Done. Okay, what if we have to multiply them together? All right, well, we're going to get 3 root x minus 2 in parentheses, and we're going to times it by the square root of x minus 5. When you do this, carefully distribute that in, you get 3x minus 15 root x minus 2 root x plus 10. We all know about combining roots together. We're going to combine these two. We're going to get minus 17 root x plus 10. That's all good. Nothing else you can do there. All right. So now it says, what about f minus g of 16? Well, since we now have a simplified version right here, we can just take our 16 and plug it in. So this becomes 2 times 4, which is 8. So we get a final answer of 11. And over here, same thing. We have multiplied our functions together, so now we can put 49 in here. We're going to get 3 times 49. Copy. Do the math. 3 times 49 is 147. And then we're going to get minus 17 times 7 plus our 10. When you type it all in, you will get 38. Okay, so that is how you do multiplication of two functions together, and pretty straightforward, I hope. Hopefully there's no problems there. All right, we're going to go right on to the next lesson. So turn in your books, if you would, to lesson number 4. So on lesson number 4, same thing occurs. We have two functions, and we're going to divide them this time. So I don't think I will go through the whole process of this investigation where you pick points and divide them, I think you will see what happens rather quickly. Oh, yeah, maybe I better. I'll just quickly fill out this chart. Well, obviously you can fill out this chart from your points. I'll just quickly write them in so for the sake of time. You can follow along if you want to. So those are the values for f of x, and for the g of x, we're going to get 1, 0, -1, -2. All right. So what I want you to see right here is that when you divide them, we do have a spot that shows us some problems, and you can see it, that it's going to be where the value of g of x is 0. So right now, when we divide 6 by 1, we get 6. Here we have an undefined point. So that is really important, because you can't divide by 0. And over here, we're going to get these values. 0 divided by -5 is okay. We're allowed to do that. We just can't have 0 on the bottom. So now if we plot these points, we plot the point when x is 4, we're at 7. So 4 and 7. When x is 3, we're at 6. And when x is 2, we have an undefined value. So we'll just wait for that. So we'll see where it was going when we put that hole in. Let's go on. When x is 1, we're at 4. So now we can see where this is going to be a straight line. We can keep plotting. 0 is 3. And you can go on down. -1 is 2. You can kind of just plot in this straight line. So that's all pretty simple. But right here, because it's undefined, you need to put a hole. So when you draw your line, it actually leaves you a hole in the line, because that is an undefined value. Okay, so we're going to say that here. Explain why the domain of f of g of x is not x is an element of real numbers. And that's because we have a hole when x is 2. So we're going to say g of x, or actually the function is not defined when g of x is equal to 0, because it's on the bottom of the function. So that happens when x equals 2. So the domain is actually going to be x such that x cannot equal 2. But it's an element of real numbers except for that point. So we have to make sure we include that. Okay, so I did part C. It says sketch the graph of y equals f over g of x, showing the domain restricted by an open circle on the graph, which I did. Now they tell us, oh, okay, the first function was actually a quadratic, which we knew because it was a parabola shape. The second function was linear, nothing new to us. That would make sense. It says write and simplify an expression, and you're so glad that you know how to do this. This is our rationals chapter, and you just reviewed it. So we're good. We can divide that. Guess what you have to do first? Yep, factor. When you factor the top, you get that. There's your denominator, and now you know that you can cancel those two because we can cancel factors, and you end up with x plus 3. That is a straight line, the slope of 1, and goes through the y-axis at 3. Is that what we have in our picture? Yep. Crosses the y-axis right here at 3. Straight line, slope of 1. What's the problem? Oh, there's an undefined value when x is 2. Well, looky there. That's what you thought. That makes sense from rationals. But what we now are going to discover is that we're going to call that point a point of discontinuity. So we'll look at that on the next page. Right now it says evaluate f divided by g of -6. So pretty simple. You can just take your -6 and plug it in to our function that we have there. So we're going to say, okay, this is equal to -6 plus 3, which which is equal to negative 3. So pretty simple to evaluate once you've done the division and the simplification. All right, turn the page. Okay, so here is where it talks about this. It says, in the investigation, the graph of f divided by g of x cannot include the 0.25 since there is a domain restriction where x cannot equal 2. This results in a hole. Oh, shoot. Okay, go back. Sorry. This results in a hole in the graph represented by an open circle. We refer to this hole as a point of discontinuity. This point of discontinuity, it happens when you have two factors cancel. When a factor on the top cancels with a factor on the bottom, there's a point of discontinuity there. And we will look at that more when we get to rational functions. But that is an important thing to remember. That would be a highlight moment right there. If you were highlighting, I would highlight a point of discontinuity. It actually doesn't create an asymptote there. It just creates a hole. Okay. It says in the investigation, bullet point number 2 here, it says the quotient of a quadratic function and a linear function simplifies to a linear function with a domain restriction. This is not always the case. In many examples, the quotient of two functions cannot be reduced to a simpler function. So it doesn't always happen, it just happened to happen in that case. So in each case, write and simplify where possible an expression for f divided by g of x. Make sure we include any domain restrictions. So if we're going to divide them, we're going to go 2x plus 5, and we're going to divide by x plus 5. Does that simplify? No, it doesn't. So all we can say here is that x cannot equal negative 5. All right, let's move on to b. So here we get x squared minus 2x minus 35 divided by x minus 7. Can that simplify? Yes, because we can factor this. We're really super good at factoring. So we have minus 7 and plus 5. Copy down the bottom. Boom. Cancels. Simplifies to x plus 5. But don't forget that you have a restriction. X cannot equal 7. Because those two factors actually canceled, there will be a point of discontinuity at that 7, when x is 7. All right. Class example number 2. It says, consider the functions f of x and g of x, state the domains of f and g. So right now, the way they are, this is a parabola, and we know that it's facing upwards, so the domain is all real numbers. This is a straight line, so we will also have a domain of all real numbers. So for both f and g, the domain is all real numbers. Okay, now let's go on. It says write an expression in simplest form if we divide the two fractions. We're going to put f on the top, right quickly, and we're going to divide by g of x. When I do that, I have to factor if possible. And this does factor. So here we go. I'm going to go 2x and x. I've got 7. I need a 14. So I'm going to go 7 here for a 14. I need it to be negative, and I'm going to add a 1. Correct? I get negative 14, positive 1. My signs all work. Check the negative 7. Then I'm going to divide this by 2x plus 1. Boom. Nice to happen. Two factors cancel. So I'm left with x minus 7. But I have a restriction that x cannot equal negative 1/2. So there will be a point of discontinuity there. It says state the domain. So I guess I could write that over here. The domain would be x such that x cannot equal negative 1/2, where x is an element of real numbers. There's your actual nice little domain. Okay. Last but not least, it says explain 2 different ways to get f divided by g of 3. So, and then calculate it. So we know we could either do from the originals, we could do f, I could do f of 3 and divided by g of 3, or I could do f like that. So either one. You can start with the original 2 functions, plug in 3, or you could start with the simplified version, which is right here. That is super simple. If we do this, we're going to get 3 minus 7 if we just use the simplified version. So we get negative 4. Okay, so that's really easy to do that if you use the division first and then plug in your value of 3. Okay, a couple more things and then we're done. So on the next page, it says consider the functions f of x and g of x, take the domains of them. Oh boy. Okay, so domain, remember we can't have a 0 on the bottom, so the domain of f of x. So domain of f of x is going to be x such that x cannot equal 1. But the domain of g of x is going to be x such that x cannot equal 3. Where x is an element of real numbers. Okay, now they're doing some funky things with this. They want 3 times f of g of 2. So there's lots of ways to do this. You could do them individually. We could put them together first. I think the book does it individually first. So let's do this. Let's go 3. This means 3 times f of 2, and then oops, g of 2. So let me just okay, sorry, I just got interrupted there, but I'll try to pick up. So we're going to go 3 of f of 2, and then we're going to go g of 2. So we're going to quickly plug our 2 value into our functions. We're going to copy down the 3 and go 2 times 2. And then we're going to plug in our 2 into the g of x function, which is like that. So when we do this math, and when you do all that together, you will arrive at negative 24. Final answer. Okay. Now it says, write an expression in simplest form for f plus g of x and state any restrictions. Oh my goodness. So now what we're going to do is we're going to take the two functions, 2x over x minus 1, that's your f function, and we're going to add it to our g function. Oh wow, this is bringing back memories. Now you have to remember how to add fractions together. This is from your rationals chapter. So when you add fractions, you need a common denominator. So I'm going to choose both denominators. From this first fraction, I am missing my x minus 3, so I'm going to do that top and bottom. And from my second fraction, I'm missing x minus 1, top and bottom. And when we do the math to that, we're going to get 2x squared minus 6x plus x squared minus x. So that's when you just multiply this 2x into both of those, and the same thing with this. Multiply those together, you'll get that. Go ahead and simplify. So we have 3x squared minus 7x for x minus 1 and x minus 3. That is your simplified version. The only thing you could do there is you might be able to factor out an x on the top, but it's not going to help us go anywhere. So I'm just going to leave it like that. All you have to do now is write down my restrictions, which is x cannot equal 1 or 3. All right. So you're so glad you remember how to add fractions together from your rationals chapter. All right, next part. It says write an expression in simplest form if we divide those two fractions. So, oh my goodness. Now, when we divide them, because we have a layered cake, I'm going to write them side by side. That'll just make it a little bit easier than putting them over top of each other. And when I know that when you divide fractions, you flip them times. So I flip the second fraction, and I turn it into a times. I'm just going to write a dot there so it's less confusing than an x. So this actually isn't too bad. We like multiplying. Because we have factors, this x cancels with that x. And what I have left is 2 times x minus 3 on the top, and on the bottom all I have is x minus 1. You can leave it like that, or you can say that it's 2x minus 6. Either one is fine. X cannot equal. Now, if you recall, when you divide fractions, obviously it can equal 1 from this first one, but also 3 from here. Don't forget the 0 from there. You have to have all three restrictions, because when you divide, you have to start with the original and then flip it over and take the non-permissible value from that as well. Okay. Now then, somehow, I'm going to get to the next page, and I think actually we're done. All right, so I'll go backward just in case you needed that. Hopefully that helps you. I hope you can get it all done. Good luck. I will leave the answer key here, so if you need help, you can look there. Thanks, guys.